Good morning, good afternoon, and good evening. Hope that you are all doing well and staying safe. Here is Mariam Shref, a senior petroleum engineering student at the Lebanese American University. Welcome to the third lecture of our online course, Introduction to Python Programming, presented by a distinguished guest speaker, Dr. Abdelrahman Kotb. Dr. Kotb is a lecturer at the William Michael Barnes Department of Industrial and Systems Engineering at Texas A&M University. His research interests include building calibrated machine learning models that predict physical phenomena, studying reaction kinetics for well-bore stimulation, and CFD modeling. He has authored and co-authored 8 publications. In addition, Dr. Kutb serves as a reviewer for SPE Journal, and finally, he holds a PhD degree in petroleum engineering from Texas A&M University. So please join me in welcoming Dr. Kutb. So welcome, Doctor, and thanks for joining us today.
You're welcome, Mariam. Go ahead.
Now, as a reminder, please don't forget to drop your questions in the Q&A box. Now, without any further ado, Dr. Kutb, the mic is yours.
Thank you, Mariam. I'm happy to be here today. Good morning, everyone. Today is the third lecture for Introduction to Python Programming. And as always, I like to start by looking at where we are, what we've studied, and what we're hopefully going to cover. So I've did some restructuring. What we covered thus far is the first 2 bullet points, which is getting started in data structures, which are chapters 1 to 8 in the Introduction to Python book. And what we are going to focus on today is the third bullet point, which is we're going to continue data structures. Specifically, we're going to talk about dictionaries and tuples, and we're going to cover some regular expressions, which I believe they're their own language and their own. Hopefully, for the last lecture, we are going to try and cover as much as we can from chapters 12 to 14, which is accessing data, web data, as well as databases with Python. Depending on the timing, we'll see which parts I'm going to be focusing on. So today, we're going to be talking about data structures and regular expressions. So today, we're going to mainly focus on the 3 things that I discussed, which are dictionaries, chapter 9, tuples, chapter 10, and regular expressions, which are in chapter 11 in the book. So last time we talked about lists, and list is a linear collection of values that stay in order, while dictionary is a bag of values, each with its own label. So what does that mean? What this means is a list. Let's say if I have a list of numbers 1 to 10, and the list is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whenever I store this in memory, Python will always keep track of this order. It will keep track that 1 is followed by 2, is followed by 3, and so on. So if I'm looking for a position within the list, Python already knows that position. And what that means in the context of Python is that Python has to store this order in memory, which means that lists can tend to be slow. On the other hand, when it comes to dictionaries, Python doesn't really care about the order. It actually does not keep track of orders. And 2 people using the same dictionary can get completely different orders. So if you think about it, it's like having an assembly line versus having a bag of things where you just pick up one thing and you realize, oh, this is my wallet. You drop it, you put your hand again, you pick your keys, and so on. With the bag, if you put your hand every time, something else is gonna come with different order because bags are a bit messy. In order to create a dictionary, we use the term dict bracket. There's also other terminologies, and I'm going to show you some examples. I also wanted to show you how I changed the font in the command prompt because I remember first lecture people had some problems. Font, I'm gonna make it 36. Let's see. Starting with this sheet, I defined the dictionary as grocery. And then I said, okay, I want the key apple to have a value of 10. And by the way, these don't have to be consistent. The only thing is that for the keys have to be strings. So this is a key. This is one key, second key, third key, fourth key. But these values, they can be either strings, they can be integers, they can be floats. So for example, here I'm making a grocery list, and I am defining the key apple as 10, key candy as 5, potato as 20, soap as 10, and then I'm printing the groceries. And how it looks is actually looks very pleasing to the eye. So if you do dict_1.py, you see the dictionary. It has this this bracket shape, and then it has the key value, key value, key value. And actually, I like how Python displays dictionary for several reasons. One of the main things is if you want to write a dictionary, like let's say you don't want to write dict like this, you just want to like list. You want in list, you can just do this and put the values 1, 2, 3. In a dictionary, what you would do, you would write it exactly like this. So you would come here, copy, paste. So let's say second dictionary. If I print the second dictionary, I'm gonna get the same thing. So now I'm supposed to have 2 dictionaries. So this means the same as adding this separate keys and values to the dictionary. Okay. So last time I talked about how lists are mutable. And what I mean by mutable is that if you are allowed to change the value. Some stuff that we have discussed that are not mutable is something like a string. So for example, I'm going to open another CMD to show you what I mean. So Python, and I define a string. So let's say name is equal, and then I want list or name list is equal so name list. If I write name list, it's gonna give me Abdelrahman and John. If I want to change 0 to Mariam, so name list, and then I print name list. What I'm gonna get is, instead of Abdelrahman is gonna be removed and Mariam is gonna be added, which is gonna make it Mariam and John. So this tells me that the list is mutable. However, if I go to the string Abdelrahman and I want to change parts of the list, parts of the string, I mean, so 0, name 0 is A. If I want to change A to B, it's going to tell me that I can't. So a string is immutable. So once I have a string, the only thing I can do is I can reassign that string. So I can say name is equal Mariam. So now I've changed the whole name. So I've basically deleted Abdelrahman and replaced it by Mariam. But I can't just change parts of the string. So this, what this means in Python is that lists, like strings are immutable. However, lists are mutable. So you can change parts of the list without replacing the whole list. So how is it in dictionaries? In dictionaries, if I create a dictionary, then I create the keys and values, and then I want to change this soap instead of 1. I want to change it to 10. If this changes, this means that dictionaries are mutable. So let's see what happens. So since the value of soap changed from 1 to 10, this tells me that dictionaries are indeed mutable. So they do allow for changes. Good. So what about if I, instead of just assigning 10, I want to see if I can do addition, subtraction, division, multiplication. So I can do algebraic features. So in this case, if it works, I would also have grocery. Let's change this to 50 so that it's different, and it's going to be dictionary 3, and I get 51. So yes, indeed, dictionaries, the values. So I wanna emphasize on the key and value. So this is a key, and whatever is on the right is the value. So key value, and keys are always they're always in quotations. As I mentioned, they are strings. The next thing is, okay, so let's say I don't want to define my dictionary in that manner, in the dict sense. I want to define it in brackets. So I just say, and this is very similar to me saying grocery equal list versus grocery equal, these two are the same. This is the same as me saying grocery is equal. And if I run this, it will run. And the reason this will run is because the first grocery is going to be a list, then it's going to be a list again, then it's going to be a dictionary, then it's going to be a dictionary. So these 4 lines are basically going to replace each other. It's going to create an empty list, then create an empty list, then create an empty dictionary, then create an empty dictionary. So if I run dict 4, it's going to give me this. If I delete all this and save it and run it again, it's going to give me the same dictionary. So another way of defining the dictionary, as I mentioned, so instead of writing 1, 2, 3, 4, 5, 6 lines to define one dictionary, you can replicate all this in just one line. So apple, so write using these brackets, apples, key, value, key, value, key, value, and so on. And I can just change this to 100, then print grocery. And I get the same exactly. And in general with Python, and I think most languages, if you can make the code shorter, you should always do that. If you can make it, this makes the code more efficient, more readable, easier to edit. rather than having 6 lines to tell you one thing. Doing it in one line is more efficient. And most of the times, this actually makes your code faster. And this is not really relevant in an example like this. However, in an example where you're dealing with hundreds and thousands of millions of data points, every point of efficiency really counts. Okay. So what's the point, or how do dictionaries help us? One of the main things that dictionary help us with is reading text. In reading text, if you're trying to count the number of words, counting becomes very useful when we're using dictionaries. So, for example, there's this paragraph: the clown ran after the car, and the car ran into the tent, and the tent fell down on the clown and the car. How many words does it have? Which one has the largest count and all that? Okay. So let's start. So we have this list of names. So we created an empty dictionary called counts. And then we created a list of names. So Muhammad, Omar, Mark, Sarah, Maryam, Peter, Mark, Muhammad, Sarah, Maryam. Okay. For name in names, so this is a for loop that basically says name for name. This is a variable. I can call it whatever I want. So for x, it's gonna be the same thing. And what I'm saying is, if x not in counts, so if x is not available in counts, I want to define a key as x and define it as equal 1. Else, if the count is already, if x is already a key in the dictionary, okay, so what I'm going to do is I'm just going to add 1 to it and then print counts. So let's see what this gives us. So dict app. So now I counted. Muhammad occurs 2 times, Omar only once, Mark twice, Sarah twice, Maryam 3 times, and Peter 3 times. Okay, so again, I want to focus on or spend some time here explaining the different for loops. And the way that I like to look at these loops is to look from, and I'm going to send it back to original name, because I like to, it's better to name your value, your variable is something that is readable. So name makes sense. And name in names, so one name, because this is a singular, so this is going through the list of names, and it's getting one name at a time. So this for loop, so for the first one, it's going to be Muhammad. And then it's going to see, okay, is if Muhammad not in counts. So it's going to check counts. And it's going to say, okay, counts, name, counts of Muhammad. Since it's not in counts, because counts is empty at the beginning, it's going to say, counts of Muhammad is equal 1. And then it's going to finish the if statement and go back to the loop. And then it's going to go to Omar. Do the same thing. It's not defined. Then Mark. Then Sarah. Then Maryam. Then Peter. However, when it sees Peter for the second time, so all of these thus far, it's going to go through the first part of the if statement. However, when Peter occurs for the second time, what's going to happen is going to say, okay, Peter in names, it's Peter. So this is the second time Peter happens. And of course, this is case sensitive. if name is not in counts, so it's gonna go into counts and say, okay, no, I see Peter in the count. So what does this mean? This means that count name plus equal 1. And this line 9, is the same as having this counts name equal counts name plus 1. This is the same meaning. So if I actually, let me delete this and see, sure, I get the same exact thing. But again, if you can write your code slower, shorter, it's always better. No, most of the times. Okay. Okay. In general, you don't really like to have if statements and even loops in your Python code. Python is not in general, loops, if and if statements are not the most efficient ways in coding. And the reason this is the case is because this is a list of, let's say, how many names? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you can use a computer that's 10 years old or even 20, like 15 to 20 years old, and this calculation is going to be pretty fast. However, in a lot of times you're dealing with, in Python, you're dealing with sometimes millions of data points. And if you give a list of a million data points and say if, and you give it an if statement, it will be extremely inefficient, because every time through the loop it's doing an if statement, then I have to go through all the list, and this will take a significant amount of time. However, if you can get rid of the if statement, it will save you an n, like there's, whenever you're calculating time in Python, you think of n square log n. So n is the length of the list. It's actually, I think it's going to be n squared, and that's significant. So if you have a million, that's a million square. I need to look at the exact duration, but it's going to be significant. So this code is actually matches the same code that I had, and I actually want to compare both of them together. So what I'm seeing here is I have the same dictionary definition, I have the same list of names, and here I have the same for loop. So for name equal name in names, but instead of having if name not in counts, do this, else do this, what I'm saying is counts name, counts dot get name or 0. So what I'm saying here is that counts dot get, what this does is it is trying to get the name. So it's looking for the name in the dictionary. So again, it's going to be Muhammad, Omar, Mark, Sarah, Mariam, Peter. So for the first couple of names until the first Peter, what it's doing, it's trying to get the dictionary key, which are the names, and it's not finding. And as a result, it's just, so this is like the if statement. If you find it, so get the value. If not, give me 0. So in the first time, it's going to be 0 plus 1, so 1, 0 plus 1, 1, until you get to the second Peter, which is going to be count.get, and you will find the name. So you'll find Peter. So it's going to be Peter plus 1. So it's going to be 1 plus 1 is 2, and so on. So if I run that code, instead of 1, 2, I will get the same exact picture. And even though the results look identical, the way this code is written is very different. And I'm going to try to add something in the last lecture about timing to show you how significant these times can be. I don't know if I'm going to have time, but we'll see. The third application I wanted to show you is just, okay, so now I showed you the list of names. What about if we want to deal with a paragraph? So the clown ran after the car, and the car ran into the tent, and the tent fell down on the clown and the car. Okay, so this is a paragraph. This can be a book, a chapter in the book. This can be a full book, and yet Python will do this extremely fast. So the first thing I want to do is I'm going to split. So this is the line, and then I'm going to do line.split. And what this does, and I think we talked about this in the first lecture, is that it splits the string that you have on the space. So it's going to split into line. So I want to show you how this looks like. So I'm just going to comment everything else. Actually, I'm just going to comment this part and to show you the words. So words are line.split. So if I do, and this is what I get. The clown ran after the car, and the car ran into the tent, and the tent fell down on the clown and the car. And pretty much what this is doing is changing every word in it into its own element in a list. Okay. So what I'm doing here is I'm just adding, okay, so print words. So this is just me adding words just for aesthetics reasons. And then I'm saying counting. Then I'm doing the same for loop that I did previous. So if the key, so if this the key or clown key or ran key or after key, so it's going to be 1 1 1 1, and then here it's going to find it, so it's going to be 1 plus 1 is 2. Actually it's it's going to be different because this is capital and this is not capital. So the car and the, so then it's going to be like, oh, this is the okay, this is 2 times car ran into the, so third time, and so on. And then it's going to be print counts, and then it's going to show you how the counts. If I do this, here it is. Print, this is the list of names, list of words, counting, and then every word with its count. So the with capital T is 1 time, clown is 2 times, ran is 2 times, after 1 time, the without a capital 6 times, car 3, and 3 into 1, 10, 2, fell 1, down 1, on 1, and so on. Okay, so we've talked about I've discussed what a key is, and what, so in this case the part in quotation is the key, and the whatever is after the columns, the column is the value. But what if I only want the keys, or I only want the values, or I actually want to combine the key and value into a tuple? And that is what we're going to talk about next. But I just wanted to show you an example of how we can extract the keys and values from the dictionary. So here we're doing the same thing. Line is the clown ran after the car. Sorry, and I'm just checking to make sure. So it's the same paragraph. The clown ran after the car, and the car ran into the tent, and the tent fell down on the clown and the car. So I'm splitting the line again. For word and words, I'm doing the same counting. So count words equal count.get word or 0 plus 1. And then after I'm done, so I'm gonna get the same. I'm gonna get the same dictionary here, but here I want to see the keys by themselves. I want to see the values by themselves. So counts, which is the dictionary dot keys, counts dot values, and counts dot lines. And all of these are going to give me a list. This is going to give me the list of keys, and this is going to give me the list of values, and this is going to give me a list of tuples. And I'm going to show you what that. So if I do dict, and then app 4, here it is. I'm going to make it. So dictionary keys is a list. Clown, the, and then all the keys. And then values, 1, 2, these are the values. And finally, items. So it is the tuples. So it's a bracket with the key, comma, number, key, comma, number, key, comma, number, and so on. So this is a list, because I have these two, of tuples. So this is one tuple, second tuple, third tuple. And a tuple does not need to have two elements. It can have more than one element. It's mainly defined by this type of bracket. Okay. So what we've done thus far, we have gone through for loops of lists. So words in this case, in this, so this is the same code as previously. Words equal line.split will give you a list of words that are in this line. And if you go into for word and words and count word equal count.get word comma 0 plus 1, what this is going to do is going to get you dictionary, which is the same dictionary as this one. Okay. What if I want to get the key and value of the dictionary? So what I can do is I can say, okay, for k comma v in counts dot items, and pretty much this is the counts of items, key value, print k value. So what this is going to do is just going to give me, it's going to print each key and with respect to its value and print it on the screen. So if I do dict, yeah, the, and so. An easier way to do this is instead of having, so k, these can be anything. The reason I choose k and v is because it's intuitive for me to say key, k stands for key and v stands for value. But this can be v and k, v and k, and it's going to be the same thing. kv is the more common. I can also do, instead of dot items, I can just do in counts, and this will not work, because once I do this, what this does is that it's gonna try to look in the dictionary. However, this dot items will provide the tuple, and the k and v is gonna look into these, the tuples. Okay, so I've been talking about tuples, but we really have not discussed what tuples are thus far, what are the features of tuples, and so on. So, tuples. The only thing that we talked about tuples thus far is how they look like, which they're defined using these type of brackets. So I've actually discussed 3 types of brackets thus far, which are this type for dictionaries, this type for lists, and this type for tuples. So if we define this tuple, which is apples, 1, tomatoes, 10, and then we click on x equals 0, it's going to tell us, okay, you can think of it as in the indexing sense, you can think of it as it's in order in a way. So x of 0 is going to be apples. However, tuples are immutable, and let's see what that means. So if let's define the same tuple. So x is equal apples, 1, tomatoes, 2, x 0, and as I said, it's going to be so x of 1 is going to be 1, x of 2 tomatoes, x of 3 is, let's say I want to change this value. So x of 3, I want it to be 20, and it's going to give me an error. Tuple object does not support item assignment. And what this means in simple terms is that tuples are immutable. Once you define something in a tuple, you cannot change it. It's like a string. You cannot change it. You can pretty much replace the whole thing. So you can define x in a completely different manner and call this as 50, and this will work. But you can't just redefine a part of the tuple as 20. And this is actually the fact that something is immutable and Python knows that it's immutable. This makes it easier to store in memory, because if Python, once a tuple is defined, Python puts it in a part of memory that it knows this is not going to change. This is going to stay as is, which is going to be easier to call. Call meaning when you want part of it, it's easier to get. So it's all about efficiency. Okay. So things that you can do in tuple, you can sort, you can append, you cannot, excuse me. These are things that you cannot do in a tuple. So you cannot sort elements in a tuple. However, you can sort them in a list. You cannot append. So appending is whenever in lists, whenever you append an element, is you adding an element to the list. And you cannot also reverse in a tuple. So pretty much with a tuple, you can, and the reason why you cannot sort or you cannot append or you cannot reverse in a tuple is because this will make it mutable. This will make it that after you've defined it, you're actually changing how it looks like. Even if it's sorting, just changing the order of the elements. This for Python, this becomes a completely different object. And the same with append, or adding an element. So instead of having 3 elements, you have 4 elements. For Python, this is a new object. Reverse is the ordering in reverse, I think. I'm not sure. But again, this makes tuples more efficient. The fact that Python knows that you cannot change it, you cannot sort them, you cannot append them, you cannot reverse them. Whenever you add them to the memory, this becomes much more efficient. Okay. So tuples are comparable, and a list of tuples can be sorted. So I've been, for the last couple of minutes, I've been saying tuples are immutable, you cannot sort them, you cannot do this, you cannot do that. And yet here I'm saying that tuples can be sorted. So let's look at a couple of examples. So the first example I want to talk about, let me close this since we're done.
So in the meantime, if you have any question related to the session, kindly drop it down in the Q&A section.
Okay, so I think the recording is back on. So this is the first example that I'm going to talk about with tuples. So x is equal 1, 2, 3. This is actually a list. And if I define the second element, which is 0, 1, 2, so the 3 is equal to 3, and I print it, it should give me a new list with the third element being 20. And then I have a dictionary: apples 1, tomatoes 10, onions 5. If I want to change onions to 0, it should work. However, if B is a string and I want to change part of it, it should give me an error. And let's see if this is the case. And yes, so the first list changed to 20. Apples, tomatoes, onions changed to 0. If I'm looking for a part of the string, which is this number 2, which is the S, it's going to print it. However, if I want to change it, it's going to give me an error. And this is what I'm seeing here. The second part is I repeated the same part of the code, which is list, changing it, dictionary, changing it. However, here I wanted to see how it would do when it comes to tuples. So apples 1, tomatoes 10. So print B. So this will print the whole tuple, and then print B2. This is 0, 1, 2. It should print tomatoes. But if I want to change tomatoes to X, this is where I'm seeing whether or not it is mutable. So 2 plus 2, it's going to be 1, 2, 20. 1, 10, 0, the dictionary. The tuple is apples 1, tomatoes 10. The second element is tomato. However, when I want to change it, it gives me an error, a trackback error. Tuples object do not support item assignment. One of the things that I showed in the last lecture, or the first lecture, is we are able to determine what are the functions that we can apply to a list or a dictionary or an object that we have. So an object can be a list, dictionary, tuple. So in a list, if we print the list and then the dir, which is directory, which tells us what we can do, we should expect that we can do much more in lists over tuples. And the reason is because everything that makes a list mutable is not transferable to a tuple. So let's see. So in this case, we have, so we can the stuff with 2 underscores, I think they're with everything. What we need to look at are these things. So in lists, we can do append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. However, with tuples, the only 2 things we can do is count and index, because everything else requires us to change our tuple. So append, clear, copy, extend, insert, pop, remove, reverse, sort. These are all mutable behaviors. So the only 2 things we can do with tuples are count and index. So as I mentioned earlier, this is an example from previously, and pretty much what counts, so counts is a dictionary. What counts.item does, it gives us a list of tuples. And if I do 2 plus 4, it's going to give us the list of tuples. So in the last slide that I talked about, I talked about how tuples are compared. What does that really mean? It means that if I say, okay, is this larger than this? Is this equal to this? Python somehow understands what I'm talking about. So let's look at the example that I have. So I say, okay, print. So this is just for it to show on the screen, is 0, 1, 2 less than 5, 1, 2. And what What Python does, it looks at this at an element by element basis, meaning that it's going to compare the first two elements. Is 5 larger than 1? That's true. Then that's it. It's going to stop. I'm going to say, yes, this whole tuple is larger than this whole tuple. Okay. So if you look at this, 0 is equal 0. So it's going to go to the second one, which is 1 and 3. Is 3 larger than 1? Then yes. Even though for the third element, we're seeing that 20,000 is definitely larger than negative 44. So we're gonna say this is true. Let's add another example. So if I just switch this, these two, this should be false because this is equal. However, this is bigger than this. So this should be true, true, false. Now I'm comparing strings. So Jones is equal Jones. However, Sally is actually smaller than Sam. And the reason why this is the case is because S, A are identical. However, M is later in the alphabet over L, which makes it larger. So this is how Python thinks of letters. So again, Jones, Sally, Adam, Sam. If you look at A, capital A is actually smaller than capital J because it comes before it. So this would be false. And this should be true. Let's see if this is the case. So true, true, false, true, false. So true, true, false, true, false. Yes. So this follows our expectation. Okay. So I mentioned in the last point that a list of tuples can be sorted. So this is a list. This is a dictionary with A10, C22, B1. And if I do print detailed items, this is going to give me the list of tuples. And I can, because this is a list, I can then sort this list. So when I sort it, I expect it to sort by keys. So it should be A10, B1, C22. So if I run this code, so items is going to be A, C, B. However, when I sort it, it's going to sort through keys. So A10, B1, C22. And the benefit of that is that the d.items or dictionary.items gives us all the properties of a list. So you can append, you can do whatever you want. So you can actually add tuples to this list. So if I want to do Z is equal sorted dot d dot items and then Z dot append D5. Let's see if that works. Okay, not give me an error, so print Z. So as you can see, I added elements to the list of tuples because this is a list, so I can add it to it. However, if I want to change part of the tuple, I would not be able to. Okay. So let's move on to the last part of today's lecture, which is regular expressions. So this is how regular expressions are defined according to Wikipedia. So regular expression shortened as regex or regexp is a sequence of characters that specify a search pattern Usually, such patterns are used by string searching algorithm for find or find and replace operations on strings or for input validation. It is a technique developed in theoretical computer science and formal language theory. What I want to do in this course is to give you an idea of what regular expressions are. I believe regular expressions can be a course in their own. They're very complex. However, they once understood, properly understood, they are actually an extremely powerful tool. So what does that mean? Pretty much it's if you want to find, and this requires also a good understanding of language. So for example, we all know in English, if you ask a question, it ends with a question mark. If you have a sentence, it ends with a full stop. If you have a name, it's capitalized. If you have a name, this can be a person name, a country name, a city name, it will be capitalized. If you have a king, it's gonna say their highness, whether it's a king, queen, so Queen Elizabeth, Elizabeth of England is gonna be Her Highness, and so on. Mr. President in the case of the US. So all these, if you're looking within a large text and you want to say, okay, for example, you're looking at a script from the UN, United Nations, and you want to know who are the leaders of the countries that attended, just from the text. You would then be able to define, okay, any name that comes before president or after president, this is a person who is a leader. So I'm talking a lot. Let me show you what I mean. So regular expressions are very powerful and quite cryptic. So when I say cryptic, is that whenever you read a regular expression, most likely you will not understand. You need to be very adept in regular expressions to be able to understand what it means. And they are indeed their own language. I've seen very weird and very difficult to understand regular expressions, but for the person who made it, it made perfect sense based on the application. For example, I remember I was working on going through captions of maybe like 70,000 images, or I know actually it was 125,000 images. And these captions, I wanted to determine the names within these captions. And I created a set of regular expressions to find these. So I was like, okay, after anything that's capital is a name, but if it's within, I want to compare it to names of cities and places and say, okay, if it's within the name of cities and places, it's not it. Anyways, so this is how you can determine, or this is, I guess, very large or very big overview of how we can make regular expressions. So this symbol beginning, $sign is end, dot is any character, backslash s is white space, backslash capital S is a non-white space. The star is repeat a character 0 or more times. Star question mark is repeat character 0 or more times, non-greedy. And what I mean by non-greedy is that it doesn't really continue. So let's say you have a large word and you find the sequence you're looking for. It's going to find it only once, and that's it. It's not going to continue to the end of the string. However, in a greedy manner, which is without the question mark, it's going to keep looking until the end of the string. And plus is repeat a character 1 or more times. So unlike the star, which is 0 to 0 or more times, again, the question mark makes it non-greedy. We make a list of characters. This matches a single character in the listed set. So this case, you would be looking for vowels. If you add this symbol and then you add characters, pretty much you're telling it, I do not want to match it with anything within this list. So anything that is not in the list is going to match. So pretty much any letter, capital or non-capital, except for the capital X, Y, and Z. Here, you can actually add ranges, so A to Z. 0 to 9. So it's going to give you any letter or any number. And this is the beginning, and this is the end. As I said, I don't want to really go into the details because I believe regular expressions can be their own class. However, I also believe that you should know what they are so that when you see them, you understand what they are. And with that, I think this concludes today's class. I think we have our last class next Tuesday, and I wish you all the luck. I hope everyone is following on with the quizzes and doing well, and I hope people are finding this class beneficial. So thank you so much for having me, and I'll see you all next week.
Okay, so thank you, Doctor, for this informative session. I hope you all enjoyed this session today. We have actually 2 questions for you before we end the session. How can we concatenate 2 tuples?
How can we concatenate 2 tuples? So what we actually cannot. So the only way we can concatenate a tuple is to create a third tuple. So if you have 2 tuples and you want to concatenate them, we would have to get the elements from the tuple and then create so in a list, and then create a tuple with these elements. But you cannot concatenate 2 tuples because it's immutable.
Okay, thank you. So in the summary, what is the main difference between a tuple and a list?
Okay, so a tuple is an ordered object. So you have it in orders, and actually tuples also are in order, are ordered elements. The main difference between tuples and lists is that lists are mutable, meaning that you can change the elements in the list. You can add more elements to the list. You can concatenate 2 lists with each other. However, tuples, anything that makes the list mutable does not work with tuples. So you cannot sort tuples, you cannot concatenate tuples, you cannot add elements to the tuples. Once the tuple is created, that is it. You cannot make any changes to it. And what this means in Python, and so the reason the simple question is, why do we even have tuples? The reason we have tuples is because Python knows that they are immutable, they become much more efficient. So they store them in a way that becomes easily accessible. So they're much faster than lists, and they are much more storage-wise. They take less space than lists, even if you have the same amount of elements.
Great. So thank you, Doctor, for your time. So that's all for today. I want to highlight that this session has been recorded and it will be uploaded soon on Arab Gore's YouTube channel. So for those who missed previous lectures, they are already uploaded. Now have a nice day and see you next Tuesday.
I'll see you next week. Have a good week.